Hey everybody, it's Mrs. Dinkelman, and we're going over the last two tests in our unit where we're trying to determine whether a series converges or diverges. So the first one I'm going to talk about is the ratio test. And we're going to become really friendly with the ratio test, especially next unit when we're looking for what's called the interval of convergence. So what we're basically doing with the ratio test is we're pretending the series in the end becomes geometric. So we're just pretending that there's a ratio at the end. And so that's what this beginning part is really about. If you would like to talk about how that works, this is something I would go over in my class about how we can determine what the ratio is in the end. So if you want to kind of compare the end results of the ratio test to the geometric series test, it might help you to remember which one is going to be converge and which one's going to be diverge. This one works really well if we see factorials or exponentials or like a combination of different types of functions. So we're going to take the limit of the n plus first term over the nth term. So basically anywhere there's an n, we're going to plug in an n plus 1, and then we'll kind of leave it alone and have the n. And so we're either going to get less than 1, greater than 1, or equal to 1. So if it's less than 1, our limit, we're going to say that our series converges. If it's greater than 1, we're going to say it diverges. That's really similar, again, to the geometric series test, because that's what this is really doing. The problem is when it's equal to 1. Then we're really inconclusive because we just can't tell for sure in this particular test. So if you get 1 as your answer to your limit, basically you just chose the wrong test and you have to decide to do something different. All right, let's go ahead and look at an example. So this one takes a little bit more work sometimes just because of the setup. So again, what we're going to do is we're going to write this, and anywhere there's an n, we're going to write an n plus 1. Okay, so that's really a sub n plus 1 over a sub n. And a lot of people will just skip to this next step. I'm a little hesitant to do that, but I think you should be fine. Where we flip and multiply. Now we're going to have to combine our algebra and calculus skills here. So for this little part right here, if we have 2 to the n over 2 to the n plus 1, if we use what we know about exponents, what that's going to leave is just a 2 to the 1 down in the denominator. Okay, so we know we have that. What we need to do for this next one, and I'm just going to kind of write it separately for just a second. In my mind, I want to think about that multiplied out. You don't actually have to multiply it out if you just remember that, yeah, I'm going to get an n squared plus blah, blah, blah. I don't even care what comes next because in the denominator is also an n squared. So I have something that has the same degree, they're equal. So I look at the ratio of the coefficients. Well, it's 1 to 1. So that's a 1. So some people actually like cancel right here and say that's 1. I hesitate to do that because it's not canceling. It's the fact that it's a polynomial over a polynomial. They're the same degree and their limit is equal to 1. So I think what we get here, that limit is 1, but I do still have this 2 that's down here in the denominator. So I get 1/2 as my final result for my limit, which means this fits into the converges category. Okay. Now the root test, this one is really used when we just have something to the nth power. And again, the results are really similar to the ratio test. So I feel like I don't have to memorize a whole separate thing because if I get less than 1, it converges, greater than 1 diverges, and equal to 1 inconclusive, which again for us means we need to pick a different test. So I'm going to take the limit as n approaches infinity, and it's going to be the nth root of ln of lots of n's in here. Ln of n to the n. Okay. Well, if I have something to the nth power and I take the nth root of it, well, those are going to cancel each other out. I don't know why my limit just disappeared. That's weird. Okay, so now natural log of infinity, that's infinite. So this is really just bottom heavy, which is 0. So again, we get to be in the converges category. Maybe. Okay, I think my pen's tired of writing tonight. Okay, so go ahead and get started. Again, that with the root test, just look for anything to the nth power. That'll be a good hint that it's going to be the root test.